Hello class, welcome back to another lecture. We've been learning about the different types of bonds this week. We've talked about our ionic bonds, our covalent bonds, how our ionic bonds will transfer electrons and then their charges will attract them. Our negative goes to our positive, and how our covalent bonds will like to share electrons between each other. And our last type that we are going to learn about are metallic bonds. So, without further ado, we have a couple videos that I will put links in the um, classroom for. Just like always, just wanted to maybe help you guys see it in a new light, in a different way. And then we have our metallic bonding. So when we talk about metallic bonds, they are formed by metals and metals. So our ionic bonds are formed by our nonmetals with our metals, and our covalent bonds are formed between nonmetals, but this one is formed by just a metal and a metal. And in our metallic bonds, we share a sea of electrons with many elements. This creates very interesting chemistry where compounds can be both conductors and insulators. Conductors we've talked about are things that allow heat and electricity to go through them well. Insulators are just the opposite. So if we have an insulator, that means that heat or electricity won't go through them. For example, in my state in the United States, it gets very cold in Wyoming. And so in the walls of our house, we put this thing called insulation, which is a lot of carbon fiber. It's a very interesting material, but it's made to insulate and keep our houses warm on the inside and so that the cold can't come in. But let's go back to this idea of a sea of electrons being shared. So when we talked about covalent bonding, we said how electrons are shared. And this is a similar idea in which our electrons, we can even see our delocalized electrons are these little circles, and our metal ions are the big things in the middle. So these delocalized electrons are bouncing around between a lot of different metal ions. So in our covalent bonds, it might just be two elements, two or three or four elements right by each other. But in our metallic bonds, we have maybe 20, 40, we have a lot, maybe even 100 different different metal ions, different elements that are together. It's a large group. And within that group, the electrons, rather than sharing with just one, can share with all of them. So at some point, this electron in our top right might go all the way down and make it to this electron in the bottom left. So it's a little bit of a hard concept, I think, to understand, but it's like, I like to think of it as covalent bonding on a really big scale. So also, we have some important characteristics when we talk about metallic bonding. Our metallic bonding have a high conductivity. So that means electricity and heat will pass through them easily. When we learned about our transition metals, we talked about conductivity and how our metals in our lights and the metal that we use when we're cooking are made out of a lot of our transition metals. And this is the exact same idea when it comes to our metallic bonding. Ductility is an interesting word that we may not have heard before, but our metallic bonding is very ductile, meaning it can be stretched without changing its form. So, for example, if we have a rubber band and we stretch it really far apart and then let go, it'll go back to its original shape. So it's very ductile. Sometimes with different metals, though, if we bend a metal, it will never be able to go back to its original form. Or even if we think of plastics, sometimes we'll be bending plastic and it'll break. So that would show that it's not ductile. But our metallic bonds, we can bend a lot. It's very easy to move. And then our last one is that they're very stable, meaning that they don't like to react with other things. Our alkali metals, for example, when we learned about those, group of the periodic table that would react with water a lot would be unstable. So anything that doesn't really react is a very stable element. So another thing we want to learn about is how to classify each one of these different things. So, for example, we want to remember that our bonds between metals and nonmetals are ionic, our bonds between two nonmetals are covalent, and our bonds between metals and metals are metallic. So, for example, what kind of bonding occurs between the following compounds? So, if we look at NaCl, would it be a ionic, covalent, or metallic bond? It would help if we had our periodic table out. So let's pull that out real quickly. I have a periodic table just a little bit behind our slides. So if we remember NaCl, so Na, we have to find each of our elements. So Cl is over here on the right and Na is over here. So if we're looking at our metals, nonmetals, and metalloids, really we're looking at just metals and nonmetals for this part. Our nonmetals are over here, and our metals are everything else. So we have a metal with a nonmetal, so that means that we have an ionic bond. What about chloride, Cl2? We just said that chloride was a nonmetal, so if we have two of them combined with a nonmetal and a nonmetal, it's covalent, so covalent bond. Iron ore, so if we find iron, we have it right in the middle of our metal area. So, but this is not just any iron, it's iron ore. So ore, it means that it's a group of elements together. So we could call it an iron compound or a different word as well, but the common word used is ore. So if we have iron ore, which is a bunch of iron elements together, we would have a bunch of metals between metals and metals. So it'd be metallic. Again, we have Ca and F. So if we would go back to our calcium fluoride, would be how we said that. Our calcium is here and our fluoride is up here. So we have a metal with a nonmetal. We would go and find that our calcium fluoride is ionic. And then we have gold ore. So we have another ore. Gold is in the middle of our table because it's a metal, so it would be metallic. So that is everything that I have on bonds. I summarized everything into one little table. This is kind of everything that we've learned about, simplified down. If you'd like to use this to study, I think it's a great tool to have this in your notebooks. So all the information is just in one spot, but this is really important things to know. It has our definitions of each, an example, and our characteristics. So I hope that all is very clear, but if you have any questions, please let me know. Have a great rest of your day.